Welcome back everyone, and in today's video we are going to talk about one of the most fundamental concepts of mathematics, that is the set. So the first thing that comes to mind while talking about set is, what is a set? A set is a collection of well-defined and distinct objects or elements. These objects are called members of a set. We denote sets by capital letters like capital A, capital B, capital C, X, Y, Z, and so on. Now let us look into some of the examples of a set and some of the counter examples. For the first one, the collection of all days in a week forms a set, since we are definite about all these days. The second example, the collection of all vowels in the English alphabet, that also will form a set. The third example, the collection of all integers, rational numbers, and real numbers also forms a set. But if we look into the fourth example, like the collection of all handsome men of the state, let's say, then that will not be a set, since the term handsome is vague and is not well defined. And for the fifth example also, it has the same meaning, like the collection of all interesting books. Now the word interesting is a vague word because different people have different kind of interested books, so that will not form a set. So those are the examples and counter examples of a set. Now there are two methods how to describe a set, and those two methods are roster or tabular form, and the second one is a set builder form. Now in the roster form, what we do is that we list all the numbers of the set within braces, and we separate each and every members of the set by commas. Like if you take the example of in roster form or tabular form, if you have A to be the set of all factors of 12, then in roster form we can write A as 1, 2, 3, 4, 6, 12. And the second one, the set of all prime numbers less than 30. In roster form we can write this as 2, 3, 5, 7, 11, and we goes on until 29, all the prime numbers less than 30. So that is how we describe the set in roster form. Now the other method, that is the set builder form. So in this method we denote the set by writing only the properties in which the set is satisfied. That is, we can write it in this form, X, where X satisfies property P. If you look into the examples for writing the set in set builder form, for example number 1, if A is equal to set of all factors of 12, then in set builder form, A can be written as X, where X is a natural number and X is a factor of 12. For example number 2, if C to be the set, it contains of elements 2, 4, 8, 16, 32, and this set we can see that 2 can be read as 2 to the power 1, 4 can be read as 2 to the power 2, 8 can be read as 2 to the power 3, 2 to the power 4, and 2 to the power 5. And in set builder form, this can be written as C is equal to X, where X is equal to 2n, where n is a natural number which lies between 1 and 5. So those are some of the few examples how to illustrate a set if you want to depict it in roster form or set builder form. Some types of sets that we can look into. The first one is finite set. By the word itself, we understand that finite set is a set which has finite number of elements, like the set of natural numbers, which is less than 10. Or if you look at any set, like a set of 3 elements, like 1, 2, 3. So that will form a finite set. The second one is infinite set. Infinite set is like the opposite of finite set. So any set which has infinite number of elements, that is known as a finite set. Like the set of real numbers, the set of natural numbers, those will form infinite sets. The third one will be a null set. Now there are sets which does not have any elements. So those sets are called null set, or sometimes they are said to be an empty set, and they are denoted by the symbol phi or just 2 braces. The fourth one is singleton set. A set is said to be a singleton set if it has only one single element. It doesn't matter which type of element there is, but that is known as singleton set. The fifth one is disjoint sets. These kind of sets we must have two sets. Two sets are said to be disjoint if there does not exist any element which belongs to both the set A and the set B. So in that case, A and B are said to be disjoint sets. So we can take example of disjoint sets, like if we take the set of three elements like 1, 2, 3, and the set of another three elements 4, 5, 6. As we can see here, the two sets does not have any element in common. So these kind of sets are known as disjoint sets. Now we can look into the equal sets also. Now two sets A and B are said to be equal if they have exactly the same elements, and we can write it as A is equal to B. So those kind of elements are known as equal sets. So if we take A to be the set of letters in the words December, so that will equal to the set of letters in the words member. So in this case we say that the set A is equal to the set B, and the other set is equivalent sets. Now these equivalent sets need not to be equal sets, but they should only have equal number of elements. So any set which has equal number of elements, so those kind of sets are known as equivalent sets. The elements might be different, as long as the numbers are equal, then that we call it as equivalent sets. So those are the types of sets that we have to remember while dealing with the concept of sets. There are some important definitions that we have to understand while talking about set. The first one is the subset. If A and B are two sets, then A is said to be a subset of B if every element of A is also an element of B, and we write it by this symbol. A is a subset of B. We have to just keep in mind here that if A is a subset of B, then B is called the superset of A, and we write it in reverse form, that B is a superset of A. Now we can look into the proper subset also. If A is a subset of B and A does not equal to B, then in that case we call it A is a proper subset of B, and we can write it as A is a proper subset of B by denoting this symbol. Let's look into some of the illustrations in order to get a better understanding about the meaning of subset and proper subset. The first one, if you have the set A to be equal to 1, 2, 3, and B is equal to 1, 2, 3, 4, 5, then in this case what we see is that every element of A is also an element of B. So clearly we can say that A is a subset of B. But of course A does not equal to B, since the number of elements of B is more than the number of elements of A. For the second one, if A is equal to the set 2, 5 and B is equal to the set 5, 6, 7, then in this case, although 2 belongs to A and 2 belongs to B, but 5 belongs only to the set A but not to the set B. So we cannot say that A is a subset of B nor B is a subset of A, neither a proper subset. The third example, if we have the set A to be the set of 4 elements, that is the element 1, 2, the element 3, 2. The element is a set here, 3, 2, and the element 4. In this case, if you write 3, 2 is a subset of A, then that would be a wrong statement. Instead, we write it 3, 2 is an element of A. Now for the fourth example, if you take the example like this one, if A is equal to 2, 0, set 3, 1, 5, then for the first one, if we say that phi is an element of A, that will be a wrong statement. Because if we say that phi is an element of A, then we somehow denoted that phi is some kind of an element. But instead we write it as phi is a subset of A, but because phi denotes the empty set, and an empty set is a subset of every set. And if we write in this form also, in braces of phi is a subset of A, that also will be false, and in braces phi is an element of A, that also will be a false statement. Number 2, 231 is a subset of A, or 231 is an element of A. Both of these statements are wrong statements, since 1 is not an element of A. Although 31 is an element of A, but we cannot say that only 1 is an element of A. And similarly, 3 is not, and 231 is not an element of A, because the whole set 231 is not inside A. So both the statements are wrong. Now the next one, if you write 0 to 0, 2, 5 is a subset of A, then this of course would be a correct statement, since 0 is an element of A, 2 is an element of A, and 5 is an element of A. So yeah, that would be a subset of A. And for number 6, if you write 3, 1 is an element of A, that would be a correct statement. Instead of writing 3, 1 is a subset of A, because this set of two elements, the set of 3, 1 is inside the set A. So this set 3, 1 is an element of A. So those are the illustrations that we can look into so that we can understand better about the meaning of subset and proper subset. One of the important concepts also that we have to remember while dealing about set is the power set. If you have the set A, then if you take all the subsets of that set A, then that is known as the power set of A. So the set of all subsets of a given set A is called the power set of A, and it is denoted by PA. If the number of elements of A is M, then the number of elements of the power set of A will be 2 to the power M. So if you look into the example, if you have A is equal to the set of 3 elements, 1, 2, 3, then PA will have 8 elements, which are these elements. For example number 2, if A is equal to this kind of set, then if you look into this set, there are 2 elements. The first element is 0 and the other element is the set 2, 1. So how many subsets will be there? It will be 2 to the power 2, that will be 4. So the power set of A are this set. So what about the possible subsets of phi, or the empty sets? As we all know that the empty set does not have any elements. So, or we can say that it has 0 elements. So 2 to the power 0, that will be equal to 1. So the number of subset of the empty set will be only one subset, that will be phi itself. So the power set of A will be the set which contains only the element phi, which has only one subset. So that is the meaning of the power set of A.